Alrighty, number 33 is extremely similar to number 30. So this time we have a 0.25 meter long bar moving on parallel rails that are connected through a 6 ohm resistor as shown. And so the apparatus makes a complete circuit. You can ignore the resistance of the bar and rails. The circuit is in a uniform magnetic field, B equals 1.2 Tesla, that is directed into the page as indicated by my feathers of the figure. At an instant when the induced current in the circuit is counterclockwise and equal to 1.75 amps, what is the velocity of the bar, magnitude, and direction? So first, to get the magnitude, we know from Ohm's law, V equals IR. So our induced EMF is the current times the resistance. So that's our 1.75 amps times our resistance of 6 ohms. 1.75 amps times 6 ohms is 10.5 volts. Now our induced EMF is equal to minus d flux dt. Our flux is equal to magnetic field times the area. The magnetic field times the area. I can't write today. So the area is going to be changing as this bar sweeps out. So we're going to call that length times width, where width is equal to velocity times time. So the distance here is equal to the velocity of the bar times time. So the time derivative of that is BLV. We're not going to worry about the minus sign now. We're going to use the right-hand rule to figure that out for us. So our induced EMF is equal to BLV. So the velocity of this bar is the EMF over BL, which from Ohm's law was our 10.5 volts over our 1.2 Teslas times the length of our bar, which is 0.25 meters. So the velocity of this bar is 35 meters per second. All right, now let's see if it's moving to the right or to the left. So we know that our induced current is counterclockwise. So from our right-hand rule, that means our induced field is out of the page. So our induced B field is out of the page. Okay, so if we look at our area, we get a bunch of X's, boop, 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 boop. And then we're moving to some new area such that my induced field has to cancel it out with some out of the pages, which means those were canceling out some into the pages in order to keep my area, my flux, the same. So if I start with a bunch of into the pages, in order to keep my into the pages equal, I have to cancel them out. So because my right-hand rule told me that my induced field was out of the page, that means I had to add some out of the pages to cancel out whatever that change did. So that was extra into the pages. So we are making our area bigger, which means our velocity is to the right.